What's going on, guys? Assalamu alaikum. Welcome to Amigoscode. In this 16-hour course, yes, 16-hour course, I'm going to teach you everything you need to know about building microservices from the ground up. This is a course that a lot of you have been requesting for some time now, and I took my time and I planned everything, and yeah, I'm giving you technologies that you should know these days. If you are looking for a job, then this course will definitely help you to secure that high-paying job. If you're working for a company and you want to start building microservices, this course will help you to do that. You're going to learn how to build microservices from the ground up using latest technology. You're going to cover Spring Boot for microservices, Maven for packaging your applications using Jib. So we're going to package into a jar, from a jar into a Docker image, and from that Docker image, we're going to run it within a Kubernetes cluster. You also will learn about service discovery, which is very important, distributed tracing, message queue, both RabbitMQ and Kafka, and a bunch more. If you're new to my channel, go ahead and subscribe. Also, give me a thumbs up. Literally, just take 1 second and smash that like button so I can keep on recording courses like this. This course is currently on sale, so hurry up. There is a 30% discount code on the website, and you haven't got anything to lose. Instead, you have lots to gain and change your career. Without further ado, let's kick off this video. Hey, what's going on? So I just want to tell you that if you are not part of the Discord community, make sure to join. Because for this course right here, or actually all courses on this platform, there is a channel that you can post your questions. If you are stuck, post your questions and a lot of people will jump in and try to help you. And also be part of it. So if you see other people struggling or they have similar questions, then jump in, because that's the best way for you to improve your skills, by teaching others. And I would love you to be part of the community. So go ahead and join. And if you have any questions about this course, post them on Discord. Catch you later. Let's begin this course by building our very first microservice. This microservice will be responsible for handling customer registration. And we're going to name this microservice as customer. Some people usually, they like to call their microservices as customer and then service, but I'm just going to drop the service all completely and I'm just going to use customer. So we'll build customer first, then add an API, connect to its own database, and then we'll proceed to the next microservice and then make those two microservices talk to each other. By the end, you should have a complete understanding on how to pull all of this together. Now, how exactly are we going to achieve this? If you've been following my courses on Spring Boot, then you should know by now that Spring Boot makes it super easy for you to build Java applications. So in here, in the official page of spring.io, you can see that basically what you can do with Spring. You can write microservices, reactive programming with asynchronous, cloud, web apps, serverless, event-driven, batch, so on and so forth. So you can go and basically see how to get an application up and running super easy with Spring Boot. But in this course, you learn all of this. And what I want to show you is, so right here, because we are learning about microservices, let's just see what they have to offer. So in here, microservice architecture are the new normal, building small, self-contained, ready to run applications that can bring great flexibility and added resilience to your code. So basically, you can read more about this just to have an overview. But in a nutshell, in here, the way that we build microservices in the Spring world is using Spring Cloud. So this diagram right here is the representation of this diagram right here. And basically I've put everything together because I want to build a fully fledged system that communicates to each other with their own databases, so on and so forth. And this diagram here is much easier for you to understand what is happening. But basically at the end of this course, you'll have an understanding of all of this. But what I want to show you is if you click on Spring Cloud in here, so they give you again definition. So developing distributed systems can be challenging, and this is what the Spring Cloud project gives you. So here you can see that we have projects, we have Spring Boot, the framework, cloud, data, so on and so forth, as well as security, which I have a course on it. But right here, so again, the exact same architecture. You can see that we have service discovery, API gateway, cloud configuration, circuit breakers, tracing, testing, so on and so forth. And what I want to show you actually, if I click on projects, let's go to Spring Cloud, and right here, have a look. So this is all the sub projects within Spring Cloud. Now, obviously, we're not going to use everything in here because, as I said, you should only really take what is necessary for you to write your own microservices. And then as we move towards Kubernetes, you'll see that some of these things are not needed. But go ahead and basically have some reading on how to get all of this up and running. But later you'll see that how we're going to install Spring Cloud, so on and so forth. I'll make it super easy for you to understand with Maven multi-modules. So hopefully now you know about Spring Cloud, and within projects, you can see that we have Spring Boot. So this is what allows us to write the microservices, and then Spring Cloud allows us to bring all these microservices together. And also you've got Spring Data for databases, Spring Security for securing your microservices, so on and so forth. If you have any questions, drop me a message. Otherwise, let's start developing microservices. For this project, we're going to use Maven as our build tool. And in this page right here, which you can find a link under the description of this video, you can see that they give you the installation guide for the operating system that you have, and then how to create a simple project. So because I'm on a Mac, I'm going to use brew. So within my terminal, I'm going to say brew, install, and then Maven. So this should take a while now. And there we go. So now we have Maven. Now, if you want to make sure that Maven was successfully installed, just clear the screen and then type mvn -- and then version. And there we go. So this is the version which was installed in my machine. So now that we have Maven installed, in here in this guide, you can see that we have this command that we can use to create a project. So we say mvn archetype generate, and then we pass a couple of flags in here. So here the group ID, so this is basically our organization, and the artifact ID is the application name. And then we pass some other arguments. So copy this command and then change this according to your organization or your name, and this as well. And I already have done that, so I'm just going to paste it. There we go. And you can see that the group ID is com.amigoscode, and then the artifact ID is Amigosservices. And in fact, before I run this, let me cd into desktop and then paste the command again. There we go. And just give a second. And there we go. So now in our desktop, you can see that uses Amigoscode desktop. We have this folder right here. And what I'm going to do is cd to Amigoscode services. And then in here, I'm going to say ls. And this is the Maven file structure. So let me see if I've got a tree in here. No. So I'm going to say brute install and then tree. There we go. And now I can type tree and check this out. So this gives me now the folder structure in a very nice way. So you can see that in here, we've got the root, we have the pom.xml, src main java com Amigoscode app.java, and then the same for the test, and we are good to go. Next, let's open up this folder with IntelliJ. So in here, I do have the IntelliJ Ultimate Edition. And if you want to grab it, I would recommend you to install JetBrains Toolbox. And if you want to grab it, I recommend you getting it through JetBrains Toolbox, because this is the easiest way that you can manage all of your IDEs and perform all the upgrades, so on and so forth. So here I've got the Ultimate, and this is what you see in here. Now let me open up this folder with IntelliJ. There we go. And inside of my desktop, I do have Amigosservices, which is this folder in here. So just pretty much just click on the pom.xml or the folder, either one should work. Open as project, and just give it a second while it's downloading whatever it has to download. There we go, that's done. And what I want to show you is, so let me just put this full screen. So in here, if I go to file and then project structure, I just want to show you that I'm using Java 17. And in here, if you want to use Java 17 as well, so that everything works with no issues, just click on edit and then click on plus, and you can download the JDK. Just select 17, but in here you can see that I can download all the other versions in here. So 16, 15, 13, 11, and 1.8. So 17 is basically the one which has the long-term support as I speak. So just use 17, and then that's it. Next, let's bring in the dependencies that we need in order to start building our microservices with Spring Boot. All right, so let me go ahead and open up this folder right here. And this is basically our parent project. So we're going to use Maven multi-module so that we can have dependencies, and then let all the submodules choose which dependencies that they need to import. And we can also enforce dependencies to all microservices. So in here, what I want to do is this folder src, we're not going to need it at this point because this is the parent module. And open up the pom.xml, and in here, so we have a couple of things, so just go through it, but basically change this according to your URL if it's not. So let me just delete that and leave the properties as is. And for dependencies, so inside of dependencies, let's just get rid of this dependency inside. So we're going to have our own dependencies in a second. And then for the build and then plugin management, so you can see that we have a bunch of plugins inside. So let's also just get rid of everything. And there we go. So let me just have the empty plugins, and there we go. Now inside, let me just have the empty plugins tag, and we're going to fill this in a second. Now, the dependency that we need in here is the following. So here I'm going to say dependency management, and then within have dependencies. And the dependency that I want in here is, so dependency, so the artifact ID, so this comes from Spring Boot dependencies, and this comes from org.springframework.boot, just like so, and then choose a version. So in my case, I'm going to pick the 257, so this version right here. I'm going to show you in a second, but this I think is the latest version as I speak. So make sure that you choose the exact same version so that you have no issues. Then what I also need is to say scope and then import. So this is using the BOM, where inside of this artifact, there's a bunch of dependencies that we can use. And this is because we're not using Spring Boot as the parent project. So this is our own parent module. And then we have submodules that can use basically these dependencies inside. So if they need, for example, the Spring Boot starter web, they can just include it right here. So this is the beauty of having the dependency management. Whereas if we have dependencies in here, so dependencies, so in here, let's say that we want every single submodule to have the Lombok dependency. So here, just say Lombok, and this comes from org.project Lombok. And let's also make sure that all submodules, they have the testing artifact from Spring Boot. So here I'm going to say Spring Boot -starter and then test. And this comes from org spring framework.boot. And there we go. So let me just put this full screen. Now, finally, because we are using Spring Boot, let's have the plugin for building the artifacts. So here, let's have a plugin, and the group ID will be com.springboot.springframework, and then .boot, and then the artifact ID will be Spring Boot Maven, just like that. And also let's specify the version in here. So version, and this will come from the property. So this will be spring.boot.maven.plugin.version. And if you grab all of this and then scroll up, and inside where we have the properties, let's just paste that and then close that. And then basically what I want is to say 2.7 in here, but I just realized that this version right here is the exact same thing. So let's just take this from here and then say Spring Boot .dependencies and then version, and we can take this from here and then put it here, close that, and then inside we can say 2.5.7. and if you want, you can basically control these independently. So the Spring Boot Maven plugin as well has the exact same version. And you can see that this now is taking shape. So this should be HTTPS, and also this should be Java 17. There we go. And yeah, so this is now taking shape. So let's just basically reload the changes. And it looks like that we have an error. Oh no, that went away. But basically, if I open up Maven, so this is still red. So if I clean, you can see that the process terminated. So let's have a look. So it looks like that I'm missing the type inside of the dependency management. So that's fine. So inside in here, I'm missing the type. That's for sure. And I want this to be POM. So this is so that we can use all these dependencies for our sub projects. Now let's reload. There we go. So all good. And you can see that we have the dependencies right here. Everything has been resolved. If I open up dependencies, we have Lombok and start a test. So this is what we have included, right, for our sub projects. We also have plugins. And in here, let's now clean. So I just want to make sure that this runs. And there we go. So let's validate as well. And also works. So we haven't got anything to compile, but you can see that this is working. So obviously, if you want to grab this file, you can grab it under the description of this video so that you can follow along. And all you have to do is just change the URL, the name, the group ID, and the artifact, and off you go. Now, just to recap, so we have some properties, but really dependency management. So this is so that our sub projects can pick whatever dependency that they want, and you'll see this in a second. And then dependencies, this is so that all sub modules by default have these two dependencies without them explicitly imported in their pom.xml. And then we have the exact same thing for the build. So build management right here, and basically not everything will need this Spring Boot Maven plugin, and that's why it's inside of this plugin management. If you have any questions, drop me a message. Otherwise, let's move on. Now that we have this pom.xml right here, and this is the parent pom, let's go ahead and create our very first microservice as a sub module. So in here, what I'm going to do is right click in this folder right here, and this is the root, so Amigosservices or whatever you have named it. Right click, new, and then module. Now at this point, so this will be a Maven project. The project SDK will be Java 17, and don't tick anything, just say next. And right here, you pretty much name the microservice. So in my case, I'm going to name it as customer. So this will be a microservice that will deal with customers. And if I expand the artifact coordinates in here, so the group ID will be com.amigoscode, and then the artifact ID is customer, and then leave the version as is. Finish. And there we go. So now have a look. So we have this new folder right here. This is customer, and inside, so let's just open up the parent POM. And what I want you to notice is that we have now by default this new section in here, so modules, and this is a list of modules. So we can only have one module right here, and this is customer. Now, if I open up customer, so this will again have the exact same folder structure. So for any Maven project, so you have the pom.xml. So inside of this pom.xml, we have some properties, and basically have a look. The parent, you can see that we have this icon. So this goes to artifact Amigoscode services right here. And I usually like to flip these around just like that. And then the model version, and then this is the artifact for this project right here, which is customer. And if I open up src main, so this is basically everything is empty, and we're going to add a few things in a second. But for now, what we're going to do is let's just open up the pom.xml for our customer microservice, and let me close this for a second. And what I want to do is inside in here, let's have, so we're going to say basically we want to have the dependencies right here, and now we can bring any dependency that we want. So for now, all I want to bring is, so I'm going to say dependency, and this has the artifact ID as spring boot dash starter dash and then web, or starter dash and then web, just like that. And this comes from org.springframework.boot. There we go. So now, so in here, have a look. So you can see that this dependency right here, it comes from, so if I click on this button in here, it comes from Spring Boot dependencies.pom, so 257. So this is what we have defined in here. Have a look. So right here, so dependency management right here, we brought all of these dependencies, and now we are letting each of these microservices choose whatever dependency that they want to use. So for this microservice, we want to be able to write a RESTful API. So hence we are bringing in this dependency. At this point, this is all we need. So what we're going to do now is, let me just close this POM and also this main POM. Oh, actually I closed the wrong one. So let me just open the POM for customer. Now inside of src, so inside of customer, src main Java, let's create a new package, name it as com.amigoscode and then customer, just like that. And what I want to do is I want to basically create a new Java class, and then I'm going to say customer application, and this will have a main method, and this class we're going to annotate it with @ and then spring boot application, and here I'm going to say spring and then application dot run, and the primary source will be customer application dot class. There we go. And also we need to pass the arguments from the command line. And this is pretty much what we need. So we also need to have the application.yaml inside of resources. So here, file, and then say application.yaml, or if you prefer properties, it's completely up to you. Enter. And inside, I'm going to have server, and then I want to have the port. So I want to have control of the port, just like that. So the default is 8080. So let's say that we want this to be 8080. And we also want to name this application. So spring application name, and this will be customer. There we go. Now, what I want to do is I want to basically create a new file in here, and I'm going to name this as banner.txt, and open up Google and search for create Spring Boot banner, and click on this very first link. And in here, let's just say customer, and you can change the font if you want, but I'm just going to leave the default. Copy everything, go back, paste that in. And last but not least, what I want you to do is open up the pom.xml, and you should see this Maven button right here, or you can press Shift Command O to load the Maven changes. So we've added this dependency, so let's just make sure that this is reflected in this microservice. So if I open up, so right here we've got customer, and the only dependencies that customer has is Lombok and start a test. And this is because, so if you recall correctly, inside of dependencies, we said that we want all the microservices or all these submodules to have these two dependencies, right? But we included this one right here for this module, but it's not showing up in here because I need to reload in here. So you can reload from here or from here, either one, and you can see that you now have the dependency, and it's just taking a while to index. And there we go. Now let's open up the customer application. So this is our main method, and right click, run. And there we go. So you can see that. So let me show you the logs. Have a look. So we've got our custom banner in here, which is customer, and you can see that everything started correctly. And you can see that Tomcat started on port 8080. So there we have it. We have our first microservice. Currently, it doesn't do anything. It doesn't talk to any database, so on and so forth, but we'll add that in a second. But you see how easy it was for us to bootstrap a microservice with Spring Boot. So within this package right here, com.amigoscode.customer, let's go ahead and create the model for this microservice. So this will be customer. So this is a class. And in here, I'm going to use Lombok. So every submodule has Lombok in it. So here I'm going to say add and then data. So this is Lombok and then add, and then I'll also need the builder in here. And there we go. So we're going to come back to this class in a second, but for now, this is all we need. Now here, let's have a couple of fields. So let's have the ID as an integer. Let's also have the first name and last name as a string. And finally, let's have the email in here. There we go. Now what we're going to do is, so we've got the model. So basically we're just following the n-tier architecture, and I've got a bunch of videos covering all of this stuff, how to properly organize your application, so on and so forth. So here, let's start from the controller. So I'm going to say customer and then controller. So this will be at and then rest controller. This will also need the at request mapping. And we're going to map this to API /v1 / and then customers. And I also want to have the at SLA for J, just like that. So I can just log a couple of things. And I've just realized instead of a class, let's just use a record. And because inside we're going to pass a couple of things in a second. So just leave it like that. And now let's have a public method that will basically take a customer from the request body and then register a customer. So public void register customer. This will take a customer request, and we're going to create this in a second. There we go. And this customer request will come from the request body. So at request and then body. Let's log the customer request. So log dot and then info. So new customer registration, and inside we're going to pass the customer registration just like so. And we also need to annotate this with at and then post and then mapping so that we can fire post requests against this endpoint in here. Now let's create this class quickly. So here, new, and then Java class. This will be a record, and let's just say customer registration and then request. There we go. And what we want to pass in here is the first name. We also need the last name, and finally the email. There we go. So this is our record, and the reason why I'm using a record and not a class is because I get immutability to strings, equals, and all that stuff for free. Whereas in here, I'm actually going to use JPA in a second. Now, inside of my customer controller, so this should be actually customer registration request, just like that. Delete this, and then let's just log that instead in here, and job done. So there we go. And now let's create the service that will basically handle this request. So let's just say customer and then service, customer service, and this customer service. So let's just create this class. So create class. There we go. And let's also change this to a record and pass nothing inside for now. And if I go back in here, so what I want to do is just say customer service dot and then register customer, and then pass the customer registration request, just like that. And I need to create this method in here. So there we go. And voila. So I've got the request in here. Now let's turn this request into the customer. So here I'm going to say customer equals to, and then customer dot builder. We're going to pass the first name from the request. We also need a last name, and finally email. And all we need to do is just say build. So this is the builder pattern, and there we go. Now let me just say to do here, and we're going to do this in a second. So there you have it. So basically right here, you can see that how the application is taking shape. And what we have to do next is just get the database up and running and then configure our application so that we can store the customer to our database. And finally, we need to annotate this class with @service so that Spring initializes this as a bean for us so that we can inject it in our controller. Let's go ahead and get our database up and running so that we can connect our microservice to it. So in here, what I want you to do is under the root folder of microservices right here. So Amigosservices, actually, go ahead and say new and then file, name this as docker-compose dot and then YAML, and then press enter. Now inside, I'm going to paste some YAML configuration, which you can find under the description of this video. And if you want to learn more about Docker, go ahead and check my website. I've got a course teaching you everything you need to know about Docker. But in a nutshell, so let's just start from the top. We've got services. This is Postgres. And then this is my container right here. The image is Postgres. I'm exposing the ports. And then this is the network. And right here, I've got pgadmin. So this is the graphical user interface client. So I'm giving the name and then passing some environment variables to connect to it and exposing the port 5050 to 80 inside of the container. And right here, I've got the networks so that they can talk to each other, and then some volumes to store some data. So once you have this file, and make sure it's named as docker-compose.yaml. So you can actually run this from here if you have the Ultimate Edition, and if not, I'm going to show you how to run it through the terminal. So in here, open up your terminal or command line and make sure that you are within the project. So I'm going to type ls, and you can see that I do have this docker-compose.yaml. Now to get things up and running, just type docker space and then compose and then up and then -d for detach. Press enter,
And you can see that it's creating the network. And now it's creating the containers, so the pgadmin as well as the database. And there we go. So you can see that this was super quick. You can type docker compose and then ps, and you can see that we do have pgadmin, which is listening on port 5050, and the Postgres, which is listening on port 5432. So now that we have this database, let's connect to it. So open up your web browser, and in here type localhost and then 5050. Press enter. Just give it a second. And there we go. So you can see that, oops, the font is too big. So now we need to set a master password. So I'm just going to say password. Right, so now let's basically add a new server. And in here, I'm going to basically name this as Amigoscode. And the connection, so in here, the host, this will be Postgres. And this is because we're connecting from a container to another container right here. So if I show you inside of services, have a look, networks, Postgres in here. So this guy right here uses the exact same Postgres, or the exact same network, which is Postgres. So pgadmin uses Postgres, and right here, this is how we define the network so that these two containers can talk to each other. And if pgadmin wasn't running with Docker, you would need to say local and then host. So this is Postgres, the port is 5432, leave the database maintenance, the username, so this is Amigoscode, and the password is password. There we go. I can save the password, and to be honest, this is it. So click on save, and you can see that we managed to connect to our database. So I can click on it, and you can see that there is not much information in here, but basically if I expand in here, you can see that we have databases, and by default we have Amigoscode and Postgres. So now we have a database that we can work with. Next, let's configure our microservice to connect to it. So within IntelliJ, what I want to do is, let me just close all of these tabs. So close all tabs, and let's start fresh. So inside of our customer microservice, open up application.yaml. And in here, what I'm going to do is paste this configuration, and you can find this under the description of this video. And also, if you want to learn more about Spring Data JPA, you can check my website where I've got a course on this, teaching you everything you need to know about connecting to databases, joins, how to model your table, queries, so on and so forth. So it's a very in-depth course, which you should take. So in here, what I have is the data source key right here, and within it, I do have the username. So this is Amigoscode, and the URL, this is PostgreSQL localhost right here. And the reason why it's localhost is because our application right here, when we start, it's not a container. If it was a container, then we would need to connect via the network. But in here, you can see we also have the port and customer. So I'm going to come back to this in a second. We've got the password, which is password. And then here we have some configuration to set the dialect, format SQL, update when we update our entities, and then show some SQL. Now this customer right here, so this is the name of the database that we have to connect to. So if I go back to pgadmin, inside of databases, create database, and then the owner is Amigoscode, and here let's just say customer. I'm going to say save, and there we go. So now we have this database that we can connect to it. Now, the last thing that we have to do is to open up the pom.xml, and in here we brought this dependency, so start a web. So this is for RESTful APIs, but we also want the dependency that allows us to perform queries and interact with our database. So in here, let me just put this full screen, and this is Spring, and then boot, and then starter, and then JPA or data JPA. There we go. And what we also need to bring in is the Postgres driver. So dependency, and this will be PostgreSQL, and this is from org.postgresql, and you can see that this is coming from the parent POM, and in here I'm going to say that the scope for this is runtime. There we go. Now go ahead and basically reload, so the changes are picked up. If I open up Maven in a second, you should see that we now have data JPA in here, as well as the PostgreSQL driver. So all good. Now let's open up the customer class, and in here we need a couple of things. So one, we need the @ and then entity annotation, and also we need @all_args constructor, and also no arg constructor in here. We're not done yet, so we need to annotate this with @ and then ID, and the ID will be based off a sequence. So let's just have the sequence generator and then import sequence generator. And finally, we need to have the generated value, just like so. And let's import the generated value as well as the type. So I think at this point is trying to basically have a star. So here, let me just say type, so generation type, and we are good to go. So with this in place, let's now create a new interface. So this will be customer repository. This will extend, and then JPA repository, where the entity is customer and the data type for the ID is an integer. Now what we need to do is open up the customer service, and inside of this record we're going to inject it, so customer repository, so that we can basically save our customer. And for this to do right here, store customer in DB, let's just say the repository, so repository dot and then save, and then our customer. Job done, and delete this to do. Obviously there are more checks that we have to do, but for now this should basically save customers in our database. Now let's start the application, and hopefully this works. And there we go. You can see that we have some logging, and here create table, so ID, email, first name, last name, and then the key is the primary key is the ID, and we also have the sequence. So this is good stuff. So now what I want you to do is to open up pgadmin, and within Amigoscode databases, customer, and then open up schemas. So we have one schema, and this is the public schema. Open that up, and then we should have one table inside. And in fact, let me just refresh. There we go. And now if I open up tables, have a look. We have the customer table in here, and also the sequence, which is right here. So customer ID sequence. So this is really cool. So if you want, you can basically count the number of rows. So this will give you 0. So there is nothing inside, and you can even basically run queries against this. So you could say, for example, select star from and then customer, and then run this, and you can see that this gives us back. But you can see that we actually are connected to our database, and we have a table called customer based off our entity. Now what I want to do is send a post request into my API and see whether we can save a customer. So I'm going to use Postman as my REST client, and you can use any other. So in here within Postman, new request to, so this will be a post, and the URL will be localhost, and then 8080 v1 customers, select body, raw, from text to JSON, and in the body, let's have this JSON blob. So first name, last name, email, Jamila Ahmed, J Ahmed, And this JSON object right here corresponds to, so if I go back in here, so corresponds to this guy here. So if I open up the customer registration request, so it maps to this record, first name, last name, and email. So if I go back and then let's try and send the request and see whether it works. So send, there we go, 200 status code, which means that we most likely have saved this customer to our database. So here, I'm just going to rerun the exact same query and have a look. So now we have Jamila Ahmed in here. So this is beautiful. And you can see that how we now have our microservice connected to its own database.
So we've managed to build customer. Now let's build a second microservice. And the idea with this microservice is that in order for a customer or a person to be a customer in our system, we're going to perform a fraud check. So we'll have a second microservice, and this microservice responsibility is just to perform fraud checks, i.e. if the customer is fraudulent. And obviously we're not going to use an external provider for checking whether someone is fraudster or not. And instead we're going to mock things by just pretty much just returning true. But you'll see that how we basically handle the responsibility to a second microservice, which is only focused on the fraud knowledge, right? So if the fraud microservice, or if the fraud knowledge increases, then it's actually independent from the customer microservice. So you can have one team which is focusing on the customer side of things, and then you've got another team which is focusing on the fraud aspects of your application. So let's kick off this section.
So within IntelliJ, let's create a new module, and this will be the fraud module. So this will be a Maven project, and then next, and this will be fraud right here. So this will represent the fraud microservice, and leave everything as is. Then finish. And let me just say, don't ask. So I'll be pushing this to Git in a second. So cancel. And here we have our fraud module. Now let's add the dependencies within our POM. So inside of our POM, what we need is a dependencies section. So here, dependencies. And then inside, for now, let's just have the Spring Boot Starter Web. And let me just close this. There we go. And within SRC, and by the way, you can see that this is already configured. So the parent is Amigosservices right here. And you can see that we can navigate to the parent POM. And within the parent POM, we have this module inside of modules already added for us. So let me go back to this POM. So this now is looking good. We're going to add the database dependencies in a second, but now within main Java, let's create a new package. This will be com.amigoscode and then fraud. There we go. And let's have the fraud application. So this will be our main class. There you go. Now let's annotate this with add, and then Spring, and then boot application. And within we have to have the main. And now let's just say Spring application dot run. We pass fraud application dot class inside. And also we pass the arguments. And to be honest, this is it. So let's just make sure that this is configured correctly. Now, always when you add something to your POM, so in here, always reload so that you can pick up the dependencies. So if I click on Maven and then go to, we should see fraud in here. So if I expand this dependencies, you can see that starter web is not in here. Now you can reload from here or from here. So either one will work. So reload, and you should see that we have the starter web. If I close this, now within fraud application, I can pretty much just run the application. And there we go. So you can see that it is running. Now, one thing that we have to configure is the port. So Tomcat started on port 8080. Now, if you have customer, so the customer microservice up and running, this will fail because customer is using this port. So let's just configure that. So here, within resources, we need the application.yaml. So file application.yaml. And then let me go to customer, and within source, and then main resources, let's take the application.yaml and let's copy all of this. So I'm going to paste this here, or actually not there, but in here, paste that, and let's use 8081. And then for the application name, this will be fraud. There we go. And we also need the banner.txt. And you can go to that website to generate a banner like this. So this now says fraud, and we are good to go. Now, if I restart the application, there we go. You can see that it started correctly. It's running on port 8081. Let me also start customer just to make sure that customer starts correctly. So within the customer package, open up the customer application and then run. And there we go. So you can see that we have customer up and running as well. Now let me just stop customer because we're not going to develop anything for now. But you can see that we successfully managed to have a second microservice up and running. Next, let's add the database to this microservice. In a typical microservice architecture, you kind of want to have one database per microservice. Now, because I'm running out of resources and I'm using the Mac M1, and if I basically have a bunch of containers for different database servers or instances, then I'm going to run out of space very soon. So what I'm going to do is within our main server, so Amigoscode, let's have yet another database inside. So we have customer. So let's also create the fraud database. So save. And basically what I'm saying is, so within our Docker Compose in here, you can see that we have services, and this is Postgres. And basically what I'm saying is we would need basically to have another service for fraud, right? But so this you'd say, for example, Postgres and then fraud. But because I'm going to run out of resources in my computer, so I'm just going to reuse the exact same database instance and have a database inside. But ideally, again, in a microservice architecture, you want to have the database servers independently. Now let's add the configuration. So I'm going to copy from the customer microservice in here. So let's just copy the data source. So all of this will be the exact same thing. So application.yaml, and then paste that in. And I need to indent this a little bit. Now this is a valid configuration. And now instead of customer, this will be fraud, because now we have the fraud database in here, and the username will be Amigoscode, and the password will also be password. But as I said, so this usually would be a different database, but in our case, we're just reusing the exact same instance, and then within it, we have the fraud database. So now let's open up the pom.xml for fraud, and we need to add the Spring Data JPA as well as the Postgres driver in here. So make sure that you have these two dependencies the same way that we've done for customer. And now what we're going to do is within our main package, let's create a new Java class, and we're going to name this as fraud check history. And within it, we need the add data, builder, all our constructors, and no R constructors, and make sure to import all of these. And we also need the @entity. So this is for JPA, and within it, let's have the ID. So the ID will be the same way that we've done with customer, but we're going to have the sequence for fraud instead. So @ and then ID. Let's have the sequence generator. Make sure that this is for fraud. So here, make sure that the name is fraud ID sequence and fraud ID sequence for the sequence name. Let's also have the generated value, and let's import this. The same for type. And last but not least, we need the ID. So private integer and then ID. Let's also have the customer ID, just like that. I also want to have a Boolean just to make sure that we store the result whether the customer is a fraudster or not. So is fraudster. And finally, I want to record when this check took place. So local and then date time and created and then @. And to be honest, this is it. Now what we have to do is restart the fraud microservice and just make sure that everything works. There we go. You see that we have create table and we also have the sequence. If I open up pgadmin and in here, refresh, and then if I go to schemas, public, we should have one sequence, fraud ID sequence, as well as one table with all these 4 columns. Next, let's go ahead and build the controller, service, as well as the repository. So we have the entity set up. Let's have the repository for it. So this will be an interface in here, and we're going to name this as fraud check history repository. Press enter, and let me put this full screen. This extends JPA repository. This is check history or fraud check history, and then integer. Oops, not that, but integer, just like that. And let me put it like that. And now let's have the controller. So here, or let's have the service. So I'm going to basically fraud check and then service. So in here, let's just have a class, and then I want to name this as service. And this time I think let's not use records because I don't want to confuse you guys. So I'm going to change the customer as well to use a normal class, because I think it's easy for anyone to understand whether you're not using the latest version of Java or not. But in here, what we want to do is just to perform a check for a particular customer. So here I'm going to say public and then Boolean is fraudulent and then customer, and we're going to take the customer ID. So integer customer ID, just like that. And in here, so what we're going to do is basically, for now, we're going to make sure that everybody, it's not a fraudster. So I'm just going to return false. So let's just return false. But obviously, if you were doing this for real, maybe you would use a third-party system, or you could have your own system that checks whether a customer is a fraudster or not, maybe checking their email against so on and so forth, and all kind of things that you can do. But in our case, we're just going to return false in here, but also we want to store the fact that there was a check that took place. So private, final, and then fraud. And then we want the history repository, just like that, and then add to a constructor parameter. And there we go. Now, obviously, I want to basically store the fact that this took place, dot, and then save. And then inside, I'm going to say fraud check history, dot, and then builder. And in between, so before I build, I want to set a couple of things. I want to set the, so set is fraudster. I'm going to say false in here, and dot, let's also set the customer ID. So this will be customer ID. And finally, I want to set when this took place. So created at, this will be local date now, just like that. And then we build, and then we basically store this in our database. And we are storing the fact that a check took place. Now here, let's annotate this with add and then service. There we go. And let's also have the controller. So class, and then I'm going to say fraud controller. This will have at rest controller, at request mapping. This will be API /v1 / and then fraud and then dash check. There we go. And this will be a post and then mapping. And here we're going to say public, and the return type will be a fraud check response. So I'm going to say fraud and then check response is fraudster. And let's just create this. So this will be a record. So create record, and inside I'm going to say is and then fraudster, and this will be type boolean. So this is all I need. Then if you want to include more things in it, then you can. Now for this post mapping, all I need is to receive the customer ID. So here, this will be a path variable or a path in here. And I'm going to say this as customer ID, just like that. And if I put this full screen, we say this will be a path at and then path and then variable. This will be customer ID. The type is integer, customer ID. And let me just put this like that. And now I can have the service. So private fraud and then check service. There we go. And make sure that this is final and add this to constructor. There we go. And now all I need to do is just say fraud check service, and then is fraud, pass the customer ID. And all I'm going to do is extract this to a variable. And I want to say is fraudulent customer. Put this on a new line so you can see everything properly. Now I'm going to say return new fraud check response, and then pass is and then fraudulent customer. And I've just realized that this must be a get mapping instead of a post mapping, and import that. And also, instead of us doing all of this shenanigans, what we're going to do is basically having private final and then the constructor in here. I kind of forgot that we have Lombok, so let's just in here. And if I go back for a second, so we just have to delete the constructor, and in here we can say at and then all our constructor, and you can see the error goes away. Let's just do this for basically everything. So the check service, so we'll delete the constructor in here, and we pass the annotation, so at all our constructor. Let's take this and let's do the same for customer. So customer service, so we'll change this from the record to a regular class. And in here, let's just take this from here, private final customer repository, and stick the annotation in there. Beautiful stuff. Let's also do it for the controller. So annotation in there, take this guy, change it to a class instead, and then private, paste that in, and let's make this final. So the records gives us a bunch of things that we don't need for our services, and I think this is much better. Okie dokie. So now that we have this fraud controller, next let's understand how the communication between microservices will work. So we have customer, which is running on port 8080, and we have fraud, which is running on port 8081. Now we want this microservice to send a request to this other microservice called fraud to check whether a particular customer which is being registered is a fraudster. Now, there are multiple ways that we can achieve this. One is to use REST template, which I'm going to show you first, and then I'm going to show you how to add service discovery so that we can eliminate the use of the ports. And then I'm going to show you also how to use OpenFA, which is my favorite way. Now, let's go back to IntelliJ, and within our customer microservice, open up customer service. And in here, remember, we had this method register customer, and we have a couple of to-dos. But basically what we want is to have this to do where, so to do check if fraudster. And also what I want to do is, so another to do here, I want to basically send notification. Now, obviously we now have the ability to check whether a customer is a fraudster. So in order for us to send a HTTP request to fraud microservice, let's have a class in here called customer config. Let's annotate this with add configuration. Inside, let's have a public method. This will return a REST and then template. And then in here, I'm going to return new and then REST template. Now, obviously we can configure the REST template, but at this point we're not going to, because I'm going to show you a better way of doing this. Now, obviously we need to annotate this with @bin, and off we go. Now, within our service, we can inject this by just saying private final REST template, and there we go. Now, inside in here, so line 22, we can complete this to do. So here we're going to say REST template dot and then query get for object, and inside we're going to pass a couple of things. So one is the URL, so this will be http://localhost:/, and then the port which the fraud microservice is running is 8081, and then /API/v1 / and if you don't remember, inside of the fraud controller we have fraud and then check. So here fraud check, and also we have to pass, so / and then customer ID, and then curly brackets, and then customer and then ID, just like that. And then here I'm going to say comma, and then we need to pass the response type. So at this point, let's just basically, so in here, fraud check response, we're going to copy this. So let's copy this, and I'll show you a better way of doing this, right? So here, let's just copy this class. So fraud check response, and then within our service, we can say that this will be a fraud check response.class, comma, and now we need to pass the ID. So basically in here, you can see that we registered the customer after. So let's change this for a second. And what we want to do is we want to save the customer at this point. And in here, I'm going to say save and flush so that we can have access to the customer ID. And now on the entity, so if I don't say save and flush, then the ID will be null. So here we are saving and then flushing. And if you want to learn more about the entity lifecycle, go ahead and check my Spring Data JPA course. So now customer dot and then get ID. And there we go. And now I'm going to extract this to a variable. And this is the response right here. So I'm going to name this to fraud check response. And then if the fraud check response dot is fraudster, so if it is fraudster, we basically want to throw maybe a new illegal, and maybe you want to have your own exceptions, but here I'm just going to say state exception for now, and then I'm just going to say fraudster, and also you can have a better message just like that. And we have to check for null pointer exception as well, so you can assert in here. But at this point right here, so we save and flush the customer, and perhaps we could have some other logic just to make sure that the same customer is not trying to register with the same email, so on and so forth, right? But you can see this is why we have these checks. And also I can see that I'm missing // so http colon / localhost colon 8081. So there you have it. Next, let's go ahead and test these changes. Okie dokie. Now let's go ahead and start the fraud microservice. And let's also start the customer microservice. So I'm going to start both. So fraud is up and running. Now customer, just give it a second. And there we go. So they are both up and running. Now what I'm going to do is let me open up Postman again in here. So I still have the Jamila payload, and I'm just going to send this request. So again, this is post to customer 8080 API v1 and then customers, send, and check this out. So we have a 200 status code. Now at this point, let me just open up PG admin, and in here, let's basically check the customer database as well as fraud, just to make sure that the request did work. So in here, let me just refresh everything. So refresh and open up customer. So in here, right click and then open up query tool, and then say select star from and then customer. And if you run this query, have a look, we have Jamila Ahmed in here. So this is cool. And by the way, if you have duplicates, that's fine because I've deleted the previous record. Now here, let me open up the fraud database, right click, and then I'm going to say query tool on that as well. And here I'm going to say select star from, and then the table name was, so within schemas, so tables, we have fraud check history. So fraud check and then history. And then if I run this request in here, check this out. So it indeed worked. So this was the timestamp. This is the customer ID. You can see that this is one, which corresponds to this one, which is Jamila right here. And in here, so you can see that Jamila, she's not a fraudster. So there you have it. So you can see that we've managed to have our microservices talk to each other. Now, one thing that I want to do is just to add some logging. So inside of fraud controller in here, I'm going to add @ and then S LA4J, and then I'm going to say log dot and then info, and here I'm going to say fraud check request for customer, and then in here I'm going to pass the customer ID. So there we go. So I just want some logging so that I don't have to check the databases that often. And let's make sure that we have one on customer as well. So customer controller, and indeed we have the logging in here. So far, you've seen that customer talks to fraud microservice on port 8081 via HTTP. Now in here, we only have one instance of customer and one instance of fraud. But what about if fraud gets too busy and we have to bring up a second instance? Now you can see that customer can talk to fraud via this port 8081, but also via this port, which is 8085. Now, in order for this to be possible, customer would need to know all the existing ports for fraud. Now, you can see that this is a problem. If fraud scales to, let's say, 10 instances, then customer needs to know about all of those 10 instances, i.e. all of their ports and where they are running. And this is when service registry comes to rescue. And in this course, we're going to kick off with Eureka Service Discovery, but later as we move to Kubernetes, you will see that we won't need Eureka Server at all. But still good practice for you to fully understand how it works. So service discovery is the process of automatically detecting devices and services on a network. So on this side, we have our microservices. So because we are using Eureka, we're going to refer as the Eureka clients. And then we also have the server itself. Now, the server, this is where the clients will register themselves. So when they register, the server will know the exact information where the service is running, i.e. the host as well as the port. Then the microservices as well, whenever they need to talk to another microservice, they will basically look up to this server as well. And this is how they can connect with each other. So the server knows all the client applications running on each port and IP address. And now let me demonstrate to you how it works if we were to have two instances of fraud. So before I said that customer would need to know all the ports for fraud, i.e. 80, 81, as well as 80, 82 or 80, 85, right? Now, customer, the first thing that it does, registers itself as a client to the Eureka server. The same with fraud. So this instance of fraud, as well as this instance of fraud. So now this server right here has information about the IP addresses as well as the ports for all microservices. Then if customer wants to talk to fraud, let's say through HTTP, the first thing that it does, it sends a service discovery request, i.e. where does fraud lives. Then the server in here will return the address for one of these services, i.e. this one right here or this one running on port 8082. And then off it goes the request to, for example, let's say this instance of fraud. So this is how it works. Now you can see that in here we have a bottleneck. So this Eureka server, if for whatever reason it goes down, so if this goes down, then you can see that how all of these microservices are meant to talk to each other. So this is why it's very important that we do our best to keep this server up and running at all costs. But later, as you'll see when we move to Kubernetes, we won't need to use this Eureka server, which will be one less pet for us to worry about. Next, let's go ahead and install the Spring Cloud dependency in order for us to set all of this up. Okie dokie. So in this section, let's learn about Spring Cloud Sleuth. So Sleuth provides Spring Boot auto configuration for distributed tracing. It configures everything you need to get started. So this includes where the tracer data spans, how many traces to keep, i.e. sampling, and if remote fields are sent to which libraries are traced. Now, this pretty much just adds a trace and span IDs to SLA4J MDC. And MDC stands for Mapped Diagnostic Context, and it pretty much provides a way for us to enrich data, i.e. the log data, so that we can correlate data across multiple services. So in here, you can see instrument common ingress and egress points from Spring applications, servlet filters, REST template, schedule actions, message channels, fake clients, and others. And if Zipkin is available, then it basically sends the traces via HTTP on this port right here, which Zipkin should be listening on. And we'll configure this in a second. So obviously you can basically have a look at the configuration, which I'm going to show you in a second. But to be honest, this is a very simple example. And what I want to do is, so if you click on learn, so in here, go to learn, and then go to the reference docs, and you can pretty much just click on any of these links right here to learn more about it. So in here, if I click on getting started, and then what I want to show you is, so basically have a look. So the following image shows how span and trace look in a system. So if I zoom in, there we go. So in here, we have a request, and at this point, there is no trace nor span ID. So the span is the basic unit of work. And then we have the trace ID. So this is the ID which is unique on a different service. So in here, have a look. We have a request that is sent. So right here, there is no trace ID nor span ID. And as it goes through the service 1, have a look, the trace ID becomes X. So throughout the entire system, the trace ID will be the exact same thing. The request goes from service 1, 2, 3, 4, all the way back. And if you look at the trace ID, they're all the exact same thing. But what changes is the span ID. So as it lands on service 1, the span ID is A. Then as it transitions to service 2, it becomes B. Then you can have a custom span ID in here, becomes C. Then as it goes through service 3, becomes D in here. And you can see that you can also generate a custom span ID, but all the way back, you can see that basically it goes all the way to F. And then as it goes back, you can see that it basically matches from the request to response. So let's go ahead together and add this library. So in here, if I close this and let me go back and let's add Spring Cloud Sleuth to our microservices. All applications have been restarted. Now let's open up Postman. And what I want to do is send a request to customer microservice. There we go. Status code 200. Now let's open up the Zipkin dashboard. And in here, what we're going to do is, so you can see that it says find a trace. So just pretty much click on run and then query and have a look. So have a look in here. We kind of have a bunch of requests, but one, so a few seconds ago, this is from the Eureka server, and that's because we did install it. But the one which I want to show you is this one here. So customer right here. So this one, which has 5 spans, and the duration was, so this was actually quite slow. I think it's because on startup, it takes a long time. But I'm going to send yet another request. So we see some improvements in here. But in here, what we can do is we can expand this, and you can see that this is the trace ID. And then these are all the microservices which are involved for this trace. So we have customer, notification, and fraud. So let's go ahead and click on show and check this out. So this is kind of cool. So you can see that the request started on customer, and this was the path. So post API v1 customers, and this is the time that it took right here. So this took 2.798, almost 3 seconds in total. But I think it's on startup, things are a bit slow. But then from customer, we made a request to fraud. So have a look. So at this point, somewhere in customer, we made a request to fraud, and this was API v1 fraud check, passing the customer ID. This was really quick. And then we sent a notification in here. So after the fraud check, we then sent a notification. So we can click on this individual call in here, and you can see some more information. Have a look, the controller class, the MVC method, the client address, the same for post in here. And if I click on that, you can click on show all annotations, and then you can have more information. So the server start time and the finish time. So you can see that this is really cool. Also, you can basically download the JSON in here if you need to. But have a look in here. We have the duration, 3 services involved. The depth was 2, 1, 2, and a total of 3 spans with 1 trace ID. Now, what I want to do is send yet another request. So I'm just going to keep things as is, send, and this time you can see that it was much quicker. So in here, let me click to find a trace, run a query. It was this one right here. And now it didn't take 2 seconds. So this time it was super fast. Have a look. So this is really cool. So almost 400 milliseconds. You can click on show and you can see all the information. Now you can see that the Eureka server is actually generating a lot of noise. So let's click on show, for example. And depending whether you want this kind of information, if you need it, which I kind of doubt. Now, one thing is, so for this Eureka server, we're not storing the results to a database. So before you saw that we could store the results so that if this server crashes, then we have the data intact. So currently we're not doing that. Finally, if you click on dependencies in here, let me just click on search and have a look. So this is currently the flow for our microservices. So let me see if I can zoom in. No, zoom in doesn't really help in here, but basically I think there we go. So you can see the arrow which is going all the way across to fraud, and basically customer interacts with fraud as well as notification. Now, if you have a bunch of microservices, then you'll see all of these different arrows going to whatever direction they have to go. So this is pretty much distributed tracing, Zipking, and Spring Cloud Sleuth in action. Now, one thing which is kind of cool is that you can also, so if I click on find trace in here, so you can see that this is actually generating a lot of noise. So if I go to IntelliJ and open up logs, I basically want to grab this trace ID in here, go back, and in here search by trace ID, paste that in, and in here you see that we don't have the time it took to perform the database query, right? Because we are storing to a database from customer in fraud as well as notification. So currently we didn't configure the instrumentation for database calls, but this is something that you can do so that you have a better view on what happens in your backend. But you can see, for example, if this service right here, fraud, is taking, let's say, 2 seconds, then you know that there is something wrong in this microservice, and then you have to diagnose. The same for notification, right? So if notifications are taking a long time to be delivered, then you can basically use this to debug your applications. And finally, I forgot that you can actually search. So in here, if I click on find a trace, I can click on plus and then have a look. Service name, we've got 4 services currently. So I can click on, let's say, fraud, and you can even combine these. But if I run the query, have a look, these are the results. So this is pretty much all for this section. If you have any questions, please do let me know. Otherwise, let's move on. In this section, let's learn about load balancers, and I'm going to show you how to configure one and how it works in detail, and also show you the best way of you taking advantage of load balancers as you deploy your applications. So in a typical application, you have the clients, this is the internet, and this right here, let's say that this is a VM somewhere on the cloud with this particular public IP address. Now, so far we've been creating microservices, and we have one which is customer. So this handles customer registration. Now this right here, so this setup where you've got 1 client or 2 clients or maybe 3 clients using one particular instance to register the application is absolutely fine. If you are working on a personal project, then this is fine for you to build because the setup, it's really easy. All you have to do is you spin up an instance somewhere on the cloud with a public IP address, and then you can access this instance. So let's say that your application is becoming popular day by day and it's actually receiving more traffic. So let's say that you went from 1 or 3 clients to 10,000 clients using your application. The problem that you're going to have is that 1, you either need one really big machine, i.e. one VM with 32 or 64 cores, lots of RAM and other high spec, right? So this might solve the problem temporarily, but still doesn't scale. If you go from 10,000 clients to 100,000 clients, then basically you kind of have to do something else. So usually what you do is you have multiple replicas of your application. So in this case, customer. So here you can see that now I do have 3 instances. So this is one instance, another instance, and then yet another instance. Now, the problem here is that these clients right here that are connecting to your backend system, right? They don't know which VM to connect to. So if they all connect to this one, then this one will run out of resources, leaving you with these other instances receiving no traffic. Or maybe you could actually implement some logic in here that has a list of all IP address for all of your instances, so on and so forth. But no one does that. So how are you meant to access your applications in this scenario? Well, this is what load balancers solve. So to fully understand this, let's take our architecture that we currently have and let's introduce load balancers so you see how it works. So in here, this right here is my private network in here. And what I have is an external load balancer. So this external load balancer, this is the main entry point for any client that wants to connect to your applications. So instead of clients going directly into customer or fraud or notification, you say the main entry point is through this external load balancer. Any traffic that goes from the internet directly into these instances inside of the private network will be blocked by the firewall. So a request comes in through the load balancer, and the load balancer is actually quite smart. So there's a lot of things that you can configure within it. But let's say that you want to send a request to customer. So this request right here is sent to this other load balancer. Now, this is an internal load balancer, and the reason is because you might have multiple instances of customer or fraud or notification. So the same problem that you are solving from the outside world connecting to your services is going to apply within the private network, because these communications right here, so this is an internal communication and this is a communication from service to service. So you also need an internal load balancer. Now the configuration between this load balancer and this load balancer will be a little bit different, but I'll explain more in details in a second. And to be honest, this is load balancers. Now there are a lot of things that we have to take into account, such as TLS, certificate management, authentication. Where do you authenticate the requests? Do you authenticate the requests within every single microservice or within this external load balancer? Do you terminate TLS in here or through these services in here? How do you make your load balancer high available? Meaning that it's always up and running no matter what. Is it cross-region if you're running your application in multi-region or not? Logging, caching, path-based routing. So in here, you see that instead of having multiple external load balancers for each of our applications, we can just have one. And then based on the path, we can redirect the request to the appropriate internal load balancer. Now you can see that this actually is quite a lot of work to do. And most often when you run applications in production, you should choose a managed load balancer instead of managing your own, because this right here is the main entry point for your application. So if this load balancer dies, right? So let's say you are managing the load balancer. If it dies, then you can see that this is a sev1 incident immediately. right? So we actually let cloud providers manage this for us so that we can just, again, focus on our microservices and our own business logic. So let's take a look at the cloud load balancing provided by Google Cloud. So in here, you can see that they give you some information about it, what it is. But in here, let's just take a look. Have a look. Over 1 million queries per second. So you can see that if we were to manage our own or set up our own, then it can be quite challenging for us to reach these numbers. Seamless auto scaling. So can scale as your users and traffics grow, including easily huge, unexpected, and instantaneous spike. So maybe there's an advert going on, so you can expect, a bunch of traffic coming your way. So this scales out for you without you having to do anything. Internal load balancer. So as I was saying, for internal services. So you can see support for cutting edge protocols, HTTP, HTTP2, gRPC, HTTPS as well, load balancers. So you can see right here, cloud logging, TCP, SSL, SSL, offload, affinity, CDN, and the list goes on and on and on. The same with AWS. So they provide either an ALB or gateway load balancer or network load balancer, and they give you some information how it works in here. So the same thing as the one provided by Google Cloud. And if I click on features, for example, have a look. So these are all the features that it provides. So redirects in here, path-based routing, IAM, health checks, SSL offloading, clouds as a target, logging, so on and so forth. HTTP header based path routing. So this is really important and one that we want. And you can see all the protocols listeners, the same with the targets, whether you want to target to an IP, an instance, or a Lambda. So this is a really cool feature for serverless applications. So you can see the benefits of a managed database. Now, if we were to actually, I didn't even show you. So SSL, so certificate management. So all of this is actually integrated. Now, if we were to manage all of this ourselves, you can see that it's quite challenging. So also Nginx. So this actually provides you a load balancer as well with some of the features that you'll see, and you can read more about it, how to configure one with Nginx if you want to learn how all of this stuff works. But basically, this is why you really should use a fully managed load balancer when running your applications in production. Next, let's go ahead and learn how the load balancer works. So far, we have this implementation in here where we have the load balancer, customer, fraud, and also notification. Now, in here, we have got no asynchronous communication within these microservices. So fraud, nor customer to notification. Now, let's say that notification takes, let's say, 10 seconds to send a notification to our customers. Now, this means that from the time that clients are using our application, there will be a delay of 10 seconds in total, plus some milliseconds and whatnot. But in general, 10 seconds. Now, this is a very bad user experience. So maybe Twilio is having an incident, or Firebase, they're having an incident, and they can't really deliver messages for now, and it's taking them 10 seconds. Now, you can see that we are depending on Twilio or Firebase, because this call right here from customer to notification, it doesn't have to be immediate. So it can have a delay, right? So whether the customer receives the notification or SMS after 1 second, 2 seconds, 3 seconds, 1 minute, it doesn't really matter. What matters is from the point that when the customer registers into our system, in here, customer talks to fraud. So this call right here cannot be asynchronous because we need to check whether it's a fraudster or not. If it's not, then this call right here indeed can be asynchronous because we don't depend for any other checks to be performed. Currently, this is a problem that we need to solve. Even more, let's say that customer right here is sending lots of traffic and we only have one notification instance. Now, what happens if notification gets too busy? Well, the notification won't be able to handle the requests coming from customer nor from fraud. It's just going to be too much. Well, you might be wondering, okay, maybe we can add a second instance. So just like that. Well, it is fine, but again, still a problem because you don't know whether this will be enough. And the same, let's say that you kind of want to have 10 servers for notification. Now, this is not using resources correctly because one, it doesn't scale correctly, and also things are not asynchronous. And even worse, let's say that we kind of need to perform an upgrade on notification. So we found a bug, and in the meantime, a bunch of requests are coming through. Now, if notification, so in here, so if we get rid of notification, then it means that the entire call from here to customer, fraud, and in here notification, 0 instances, this will fail. And at this point, we already registered the customer. And the only thing that we need to do is just to send the notification. But if notification is not up and running, then the customer will be created and the response that the client will get is a 500. And you can see that this is not feasible, right? So this is pretty much what a message queue allows us to deal with. Next, let me show you the example where we slow down notification and see what happens. Within IntelliJ, I do have all of the microservices up and running. So if I click on run, you can see that I do have customer, fraud, as well as notification. Now let's send a request to the API gateway, and before the request reaches notification, let's stick a breakpoint in here. So notification is running in debug mode, and I've got this breakpoint in here. So let's open up Postman, and in here, we're going to send this payload to the API gateway, which is listening in on port 8083. And from here, you can see that this is very quick. So it takes about 941 milliseconds, give or take, right? So this is when the request goes from one end to the other. Now, if I send this request, so this actually took me to this breakpoint. And now let me go back yet to Postman and have a look. This request right here is hanging. Now, what I'm trying to simulate is the case where the request reached notification. And by the way, this is without the message queue right here. So the request reached notification. And now let's say that Twilio is taking forever, or Firebase, they are taking forever to process our notification. Now you can see that Postman is actually hanging in here. So it's saying send the request, and it's waiting forever. Now if I was just going to basically remove the breakpoint, but I can see that this probably was a timeout. And before I send the request, so let me just go to notification, and in here, let me just resume this, and eventually it sends the notification. But let me go back yet again, and let me send. So let me just wait for a second, and you'll see that. So let's just say that Twilio was having a bad day and they took some time to process the notification. Now it worked. Let's just resume back to Postman and have a look. 18 seconds to process our request, which is insane. So you can see that we have a bottleneck in here. Now within Zipkin, you can see that in here I do have the calls. So this one was the first one that took some time, and then this one was the one that took 18 seconds. So if I click on show in here, now I want you to check this out. So the request from the API gateway took 18 seconds. Customer made a request to fraud, and have a look. Fraud, you can see this line right here, which is barely visible. So this was super quick. So if I try and click on that and have a look, fraud controller, and if you show all annotations, you can see more information. But this was really quick. So this call right here was very quick. And the problem really lies within notification, which is taking 18 seconds. Have a look. This line is actually all the way through the end. So this is the bottleneck. So you can see also why having Zipkin is really important, because we can visualize all of this stuff. Now, this is when the message queue comes to rescue. So at this point, if we stick the request inside of the queue, it returns an acknowledgement back to the sender, in this case, customer. And then if notification is taking a while, then basically we don't have to wait for 18 seconds as you've seen, right? Because we know that eventually the notification will be processed. So this is why we need to use a message queue. If you have any questions, please do let me know. Otherwise, let's move on. So when it comes to decouple microservices and provide asynchronicity between them, as well as resilience, there are a couple of big players in this field. One of them is Apache Kafka. Now, Apache Kafka is open source, and I believe it was initially developed by the guys at LinkedIn, and it's basically used by a lot of companies. So it provides high throughput, it's scalable. One cool feature here is that it has permanent storage. So you can store streams of data safely in a distributed, durable, fault-tolerant cluster in here. So something that RabbitMQ, for example, does not provide. Then it's also high available. So you can stretch clusters efficiently over availability zones or connect separate clusters across geographic regions. Now, Kafka on its own, it's a big beast, I have to admit. But still, I'm going to basically show you how you're going to use Kafka with Spring Boot at a later stage. Then what we have is RabbitMQ. So RabbitMQ is the most widely developed open source message broker. For this course, we're going to begin with RabbitMQ, due to its simplicity of getting started, understanding its concept, and the integration with Spring Boot will be really straightforward, as you'll see. We also have Amazon SQS. So Amazon SQS stands for Simple Queue Service. It's a fully managed message queuing service that enables you to decouple and scale microservice distributed systems and serverless applications. So if you are deploying your applications to AWS, then this is a great solution because it's fully managed. Now, one disadvantage of using SQS is that, let's say that you want to port your microservice architecture to Google Cloud. So recently, there were a couple of regions of AWS that were down, for example. Now, in this case, if you are deploying to multi-clouds, i.e. you're deploying to AWS as well as Azure and maybe Google Cloud, let's say that you've managed to deploy to all those three at once, right? So it's It's a very difficult job, I'm not going to lie, but let's just say that you've managed to do it. Now, if you are tied to SQS, then you can't really move across any other cloud provider because SQS is AWS specific. Whereas maybe if you're running your own Kafka cluster or RabbitMQ, then you have more flexibility in here. So usually you'll see that you have teams that are dedicated for making sure that your cluster, i.e., either using Kafka or RabbitMQ, that these are always up and running. Because again, if they go down, so in here, so if you lose your message queue, then you can see that again. So if this goes, then you have a big problem. But usually it shouldn't be a problem because when running Kafka or RabbitMQ, you want to run in multi-AZ, for example, right? Multi-availability zone. So if one availability zone is down, then no matter what, things are still up and running. So you'd never have one single message queue for all of your microservices when running in production. And before I forget, I'm going to leave a link where you can learn more about the differences between Apache Kafka, RabbitMQ, and SQS so that you have a better understanding of these tools. If you have any questions, drop me a message. Otherwise, let's move on. So in order for you to understand what Kafka is, I would highly recommend you to go and enroll to this course right here, where I teach you everything about microservices in terms of setting up everything from scratch, microservice communication, connecting to databases, logging, and a bunch more. So basically everything in here that we are doing. And previously we actually did connect to a RabbitMQ in here. So if you've missed that video as well, I would highly recommend you to go and check it out. Now, because we are learning about Kafka in here, we just have to replace this part right here because Kafka can be also used as a message queue. So let's dive into Kafka to understand what it is. Kafka is a distributed streaming platform that allows producers to send events of streams right here to the broker, and then consumers can actually receive those events. And the way it works is through topics, and I'm going to explain topics in a second, but Kafka is a distributed streaming platform. Now, you might be wondering why distributed? Well, you can imagine that you want your application to be resilient, i.e. you don't want just one node to act as your Kafka broker. And instead, you can have 2, 3, 4, or thousands of nodes. So these are brokers that basically run your Kafka process. So these could be cross-region, different data centers, so on and so forth. And with Kafka, you can build real-time event-driven applications, such as, for example, location tracking. So maybe if you order food from Uber Eats, then when you see the driver updating his location on the app, that is done through Kafka. Kafka is fault tolerant, so you run a bunch of these nodes cross-region. It can scale, so if you basically need more brokers or if traffic increases, Kafka is highly scalable. And as I said, Kafka should always run as a cluster. Now, one difference here that you might be saying, okay, so what's the difference between Kafka and RabbitMQ, for example? Well, with Kafka, messages, when they are sent to the topic, they don't disappear. So they can stay there for a couple of minutes, couple of hours, couple of days, or even forever. Whereas in a traditional message queue, the messages are gone as soon as they are consumed. So we have producers and we have consumers on this side. Producers, these could be microservices or web application or anything really that wants to produce messages or events of streams. And then you have consumers. So again, this could be microservice to microservice communication, or maybe you want to send logs as well, or you want to build monitoring systems, including dashboards, or even do work with Hadoop. Also right here on the side, you can see that Kafka has something called Kafka Connect. So these are mainly for data integration. You've got Kafka Connect source. So this pulls data from your existing data sources into Kafka. And then you have Kafka Sync, which takes data of Kafka topics and then puts it into your data source. So the connect right here, so these are Java applications that run independently from the main process. There's also something called Kafka Streams. So this is a Java API, and it's mainly used for data processing and transformation. You can enrich data, you can transform data, you can perform filtering, grouping, aggregation, and a bunch more. Now here you can see that the arrows go both ways. So as data comes to Kafka, basically Streams performs all of these data processing, and then once you're done, you can actually put it back to a topic so that any other consumer that wants to consume that enriched data, they can do so. Now let's look where these events of streams are put inside of Kafka. So with Kafka, we have this concept of topic. And if you've seen my RabbitMQ, you've seen topics and different types of topics, but in Kafka, it's a little bit different. So a topic is a collection of events which is replicated and partitioned. So if you can imagine, so if you have messages going to your topic, then if you have a bunch of nodes, these are replicated and also partitioned. Now, partition here means that, so if you don't have a node which is big enough to hold this topic right here, the topic itself is actually partitioned across multiple nodes. As I said, it's durable, so you can store it for hours, days, years, or even forever. And there is nothing that says how big or small these topics can be. So there's no limit. So you have to decide what you want to store, and you can basically have really, really big topics or tiny topics. Now, in contrast to a message queue, such as RabbitMQ, as I've mentioned, a topic in here, you can think of it as a log. So if you've done any Java using log4j, storing logs to a log file, this is the exact same concept, right? So data going into the log can be kept for hours, days, years, or even forever. And once data is read off a topic, it's still there. It's still there. Whereas with a message queue, if, for example, this is read, then it's gone. But with Kafka, it's not the case, meaning that you can then have a bunch of other consumers reading off the same topic. So we have producers that stream data of records. So these are the records in here. And then we have consumers on the other side. So in our example, we are working with microservices. So we'll have a microservice that produces and another one that consumes these records. Now, let me quickly touch on partitioning. So as I said, there is nothing that says whether a topic can be small or big. So there's no size limit for them really. Now, you could have one node that is big enough to hold one topic, right? So if you have a massive topic, you can have one giant node to hold that. Or instead, what you could do is, so these days, as you know, we can scale up or down because of the cloud and resources are cheap. And we can have a node which is kind of a medium size, right? So in this case here, let's say that from a giant node, we go to 3 or 4 small nodes. Now, because we have the topic, so we have a topic, this, because it doesn't fit on these smaller nodes, we have to partition it. So here we have partition 1, partition 2, so on and so forth. This is the main idea of Kafka. Next, let's go ahead and build a project with Kafka. So you see the integration, and we're going to create the broker, which will run locally. We'll also configure a topic, producer, and consumer, and then we'll have everything working together by sending and receiving events of streams.
So we have everything configured and set up. Now let's take the jar and package up into a Docker image. From that Docker image, we can then run containers, and you'll see the benefit of Docker. If it works on my machine, then it surely works on your machine. Docker is a technology which has changed the game in terms of the way that we package software. And later you'll see with Kubernetes, it's the perfect match. If you want to learn more about Docker, I've got a complete course on Docker explaining everything in detail. But in this section, don't worry, because I'm going to simplify the process, teach you the core concepts of Docker, and make sure that you have the required knowledge to take your jar, package it into a Docker image using Jib. So we're going to use Jib. And then from that, we can run containers. And the containers that we're going to run are within a Kubernetes cluster. So I'm super excited about this section. Let's kick off.
Let's begin by understanding what exactly is Docker. Docker is a platform for building, running, and shipping applications. I think this bullet point really tells what Docker is in one single sentence. Now, bearing that Docker is a platform for building, running, and shipping applications, developers can easily build and deploy applications running in containers. Now, more in detail on containers, but you can think of a container as a running instance of our application, packaged up and running within a container. The cool thing with Docker is that local development is the same across any environment. Have you had this scenario where it kind of works in your machine, but it doesn't work on the development environment or staging environment, demo environment, production environment, because of hardware issues, installation issues, configuration, so on and so forth? Now, Docker removes all of that away. If it works on your machine, it will work in dev, staging, demo, pre-prod, prod, and basically any environment. Docker is also used a lot for CI/CD workflows, so continuous integration and delivery workflows. So we're going to touch more on CI and CD workflows later in this course, but just bear in mind that Docker is used quite a lot in the DevOps space. So let me teach you about Docker images and containers and basically how everything fits together. So how do we go from some code that we have to running a container? Now, usually when building software, you have your source code. So this could be pretty much any code written in any programming language. Now, what you as a developer do is you take that code and then you build a Docker image. Now, from this Docker image, you can run a container. So from the Docker image, you can run a container. The Docker image, you can think of it as the template for running your application. Now, the cool thing is, from one Docker image, you can actually run multiple containers. So here, for example, you can see that the container is a JavaScript application or Nginx or Postgres or pretty much anything that you want. Literally any programming language, any technology that you're used to, you can pretty much just run it as a Docker container. So a Docker image is basically a file used to execute code in a Docker container. It is a set of instructions to build a Docker container. So you've seen that from our code, we can build the Docker image, and from an image, we can run containers, right? So this is the purpose of the Docker image. From it, we can run multiple containers, right? So it contains the application code, libraries, tools, and everything needed to run our applications. You can think of a Docker image as the blueprint. And from the blueprint, we can run multiple instances of the actual thing that we want, which are containers. So a container is an isolated environment for running applications. So that's literally what it is. So this is a container. Now, this might not tell you exactly what the full picture is, but let me just go inside and tell you what the container is. So within a container, it contains everything that your application needs. It contains the operating system, it contains the tools, and also, most importantly, it contains the software. So here, let's say that this is a Spring Boot application, or it could be a JavaScript application, a Node application, a GoLand, a Python application. It could be literally any application that you have. So it contains the operating system, tools and binaries, and software. So when we run the command docker run, and then I said Amigoscode /2048, so what that gave us, it gave us the application right here. So on the left hand side is the container, and then on the right hand side is the actual application that the user interacts with.
In this section, I want to focus on Kafka, and I want to build a little project using Kafka so you see how it works. But then towards the end, I'll basically let you go off and explore how you're going to change the existing application, which is using RabbitMQ, so that you can integrate with Kafka. Now, the reason why I want to teach you Kafka is because you should know both. And you'll see that because we are using Spring Boot, then the integration with Kafka is also really straightforward. Without further ado, let's kick off this section.
Let's go ahead and learn about Kubernetes. Kubernetes originated from Google, where they've been deploying and working with containers for many years now. And internally, they have this tool called Borg. Was a very successful internal system that allowed Google to deploy billions of containers every week. From Borg, then they developed Omega, and from Omega, Kubernetes was born. Now, just to note that Kubernetes is actually written from scratch. So it shares the same DNA of Borg and Omega, and the difference here is that it's open source. So everything that developers at Google have learned over the years developing Borg and Omega, they took all of that knowledge and mistakes along the way, and they came up with Kubernetes. So Kubernetes is open source, which means that both you and I can contribute to this awesome project. Fun fact, Kubernetes is actually written in GoLand, which is an amazing language. And if you want to learn about GoLand, go ahead and check my website where I've got a course on GoLand. Now, the easiest way for you to picture Kubernetes is by looking at this picture. So here you can see that we have this cargo, and Kubernetes really, it means pilot. It's a Greek word that means helmsman or pilot. You can see that the ship has a bunch of containers, and then Kubernetes is actually managing all of these containers. Now, if you know about containers and Docker, then this should be somewhat familiar to you. And if you need to learn about Docker and containers, go ahead and check my website where I've got a course waiting for you on Docker. So let's dive a little bit deeper and understand Kubernetes. So Kubernetes, aka K8s, where the 8 is the 8 letters in between K and S, is an application orchestrator. So in this picture, you can see that we have Kubernetes, and Kubernetes orchestrates all of these applications. When we are talking about applications, we mainly refer to containers. So Kubernetes deploys and manages our containers. It also scales up and down according to demand. It performs zero downtime deployments, rollbacks, and much more. So knowing Kubernetes will set you apart from many software engineers, because right now the demand for people that understand Kubernetes is quite high, and the salary as well is super high. So knowing Kubernetes will take you a long step in your career. Now, when we talk about Kubernetes, we need to first understand what a cluster is. So a cluster is a set of nodes, where a node can be a VM or a virtual machine, and these can be running on the cloud such as AWS, Azure, or Google Cloud, or even on premises. Now, when we talk about the Kubernetes cluster, we have to understand the difference between the master node and the worker node. So the master node is simply the brains of the cluster. So this is where all of the decisions are made. And then the worker nodes, this is where all the heavy lifting work happens, such as running your applications. And both the master and the worker node, they do communicate to each other via the kubelet, which I'm going to teach you in a second. Now, within a cluster, you often have more than one worker node. And for this particular cluster, we have 4 nodes in total, 1 master node, and 3 worker nodes. Now that you know what the Kubernetes cluster consists of, next, let me go ahead and dive deep into both the master and worker nodes. So in Kubernetes, a pod is the smallest deployable unit and not containers. Now, to visualize what a pod is, I've got this really nice diagram. So this is a pod. So within a pod, you will always have one main container, and the main container represents your application, whether it's written in Node.js, JavaScript, or GoLand, whatever language that you want. Then you may or may not have init containers, and more on init containers, but they are containers which are executed before the main container. And then we might or might not have some side containers. So you could have 1 or 2, and also here whatever language that you want. Now, side containers are containers that support your main container. So for example, you might have a container which acts as a proxy to your main container. Also within pods, we can have volumes, and this is how containers share data between them. Now, the way that these containers communicate to each other within a pod is using localhost and then whatever port that they expose. The pod itself has a unique IP address, which means that if another pod wants to talk to this pod, it uses the unique IP address. So a pod is a group of 1 or more containers. It represents a running process. It shares the same network and volumes. And one thing to bear in mind here is that you should never create pods on its own. We should use controllers instead, such as, for example, a deployment. And we're going to learn exactly deployments, jobs, replica sets throughout this course, but it's good for you to understand the smallest deployable unit of Kubernetes. Now, the reason why I'm saying that you should never create pods on its own is because pods are ephemeral and disposable. Ephemeral means that they're not long-lived, therefore they are disposable. And remember, I said that Kubernetes is an orchestrator, and we have a bunch of controllers that monitor the state of our cluster. So if a pod dies, then if you create a pod on its own, then there is no way that Kubernetes knows how to manage and bring another pod for you. More on this later, but remember I said the smallest deployable unit for Docker are containers, and for Kubernetes are pods. Next, let's go ahead and learn how to create pods. So to deploy customer within Kubernetes, let me go ahead and close this file and this file, and within minikube folder, let's have a new folder, and here I'm going to name this as services, and within services let's have customer. So this will be yet another folder, and basically per microservice, we want to have a different folder with their YAMLs. Now, in order for us to deploy customer, we need the following. So here, I'm going to have a new file, and let's start with the service. So I'm going to say service dot and then YAML. Here, I'm going to use auto completion, so K, and this is a service. There we go. And here, the name will be customer, and then the port will be 80. And we're going to say the target port is 8080. So again, 80 here is so that we remove the need of specifying ports from our applications. So if I open up clients, have a look, clients-cube.properties. Here, I'm just saying customer. So customer refers to the name of this service, and the port is 80. If I had 8080 in here, then this would need to be 8080. But we don't want ports, so let's just get rid of that and leave this as 80. Now for the type, I want this to be a load balancer, and I'll explain load balancers in a second, but effectively in here we are configuring the service, and I'm saying that this will be type load balancer. Now really what we want is to have an ingress in here, but we're not quite there yet. So for now, let's just say load balancer. Now if you're running Kubernetes in, for example, EKS, that will spin up an application load balancer for you. So it will spin up an application load balancer for you. And again, we don't have this ingress yet, but I'll touch on ingresses in a second. All right, and this is pretty much everything we have to do for the service. Now let's create in here a new file, and I'm going to say deployment dot and then YAML, and here I'm going to say K, and I'm going to choose Kubernetes deployment. The name for this will be customer. Now make sure that the replicas is 1. Make sure that replicas for now is 1. And I'm going to explain this in a second why, but for now, just leave it as 1. Then for the image, we're going to say this is Amigoscode / customer column and then latest. And if you don't specify this tag, it will basically pull latest anyways. Now for image pull policy here, you can basically change this to always or never. Actually, you don't want never. So maybe you always want to pull the latest image, or if not present. And in fact, let's just say always. So because we're testing things, it doesn't really make a difference. Next, we need to define the ports. So ports, and the container port for customer is 8080. There we go. And last but not least, I want to specify the environment. And here, so remember, within our Docker Compose, we have Spring profiles active equals to Docker. So we want the same thing, but the value will be cube. So customer in here has this, oops, not there, but in here it has this application-cube.yaml. So we want to select this file. And to be honest, this is the configuration that we need. Obviously, we can configure resources, limits and requests. We can also configure the liveness and readiness probes, but this is the bare minimum configuration that you need in order to have a deployment with one replica up and running. Now, the reason why I said 1 in here is because if I open up the application-cube.yaml, in here, have a look, the Hibernate DDL auto, this is create drop. This is create drop. So it means that if a second pod comes along, it will basically destroy the database. So this right here, you only have it for testing purposes, and you can go and basically say, for example, update, so that it doesn't delete data. And in my case, I really don't care about the data, so I'm going to leave create drop. And in the replicas, I'm going to leave as 1 as well, because I also don't think I have many resources, because I only have 16 gig and I've got a lot of things already up and running on my machine. So I'm going to leave the replicas to 1. But usually you want to have 3 replicas at least, so that your application is always up and running if one fails, right? But again, this is when you go to production. For testing, you can leave it as 1, and this should be okay. And there we go. This is customer. Next, let's apply this YAML.
Okie dokie, I'm glad that you've made this far. So go ahead and enroll to the entire course. Link will be in the description of this video. 16-hour course packed with awesome content. If you're not part of the Amigoscode community, both Discord and Facebook group, I would like to see you there. And this is all for now. I'll catch you on the next one. Assalamu alaikum.